This is the Core 2 video for Systems of Inequalities. This is the classwork that we did on May 9th in one of our classes. Um, to start off with, I'm going to demonstrate how I would solve question 1. Question 1 is similar to question 4. You can do question 1 and then try question 4, and um, I will also then do question 2, which is similar to question 3. Question 1 is giving you two equations in the slope y-intercept form. Y equals mx plus b, or in this case, y is equal to or greater than the slope times x plus the y-intercept. And that's exactly what I'm going to use for the first equation. So I will start with changing my view. I'm going to take the first inequality, and I'm going to graph the line as if it were just an equation. I'm going to think of it as an equation because I can only graph the equation. It's an inequality, but I need to start with the equation because that's the boundary between, in this case, what is greater than and what is less than. So y equals negative 1 times x. I change the negative x to negative 1 times x. Actually, ultimately, I will do negative 1 over 1 plus 3. So I take the y-intercept, first of all. If x is 0, which it is on the y-axis, then I have 0 times negative 1 plus 3. Y is 3. So on the y-axis, I put a dot at 3. And then I take the number that's next to the x, the coefficient of the x, and I use that for my slope. That's why I divided it by 1. Now I have a rise and a run. So I start at my point, and I rise negative 1, because the rise is the numerator, and I run 1. And I can continue doing that, and kind of see the pattern. But really, I have enough now to input my line, or to draw a line. I only need 2 points for the line. So I'll start my line. And the computer is set to draw a dashed line. Dashed line means it cannot be equal to. The line does not represent a solution. So it cannot be equal to if I have a dashed line. And you'll notice that I do have, could be greater than or equal to. So I'm going to make it a solid line. So I have to do the properties. So that's graphing that inequality. Well, it's graphing the line. I need to graph the inequality now. I need to look at the greater than. I've graphed y equals negative x plus 3. I have to graph y is greater than negative x plus 3. Two ways to do that. And I think I'll show you one way on this one. I'll show you another way on the other ones. On this one, I'm just going to take my line, and I'm going to say on this line, y equals negative x plus 3. But I also have to consider where y is greater than negative x plus 3. So at this point, x is 1, y is 2. If I want y to be greater than, y has to be greater than 2. So I have to go above the line. Any point, I want y to be that point or greater. So I am going to shade the area above that line. And I'm going to do it lightly. Because I have to graph the other equation now, or the other inequality. And I'll do that. So y equals 3 halves. It's a fraction, but actually with a slope, fraction kind of is nice because it gives us the rise and the run. 3 halves x minus 2. And there again, first I look at my y-intercept. If x is 0, the 3 halves times 0 becomes 0. Y is just minus 2. So I go to y equals negative 2, and I put a dot. And then I look at my slope. The slope is 3 over 2, rise over run. Rise is 3, run is 2. So I rise 1, 2, 3, and I run 1, 2. So this point is actually on both lines. And I'm going to undo that. I did that just for you to see. But I'll put that point there. Now I draw the line between those 2 points. I could continue over 2, up 3, just to see my pattern. Over 2, down 3. Okay. But really all I need is the 2 points. So I'll take my points and I'll draw my line. And once again, I need to change that to solid because it could be equal to. The points on that line will satisfy the inequality. And once again, I look at, if I am on this line, at this point, for instance, then y is equal to 3x plus, minus 2. I want y to be, or y could also be less than. So at any point, y is equal to, it could also be less than. So I can have that point, or I can have what's less than. So on this one, I want to be below the line. I'm going to go back to my pencil, and I'm going to kind of shade this one, but I'm going to make this one with broader lines. And to graph the inequality, I really need to shade the area that is covered by both. So my shading actually goes in this area. This area meets the criteria of both inequalities. If you want to pause the video now, and since I did this lightly, I'm going to kind of erase the other shading that I did, because in the end, I really just want to shade the area that is covered by both. I just did the extra shading to show you how it's done. Okay, pause the video, try number 4, and see if you can do that one. When you come back from the video, I will do number 2. Okay, now that you've tried number 4, number 2 is very similar to number 1, except for one important difference. I no longer have y by itself on one side of the inequality. I have x and y on the same side of the inequality. That's what we call standard form. Standard form, 2 approaches. One way you could rearrange it to have y-intercept form. Another idea is just to try different values. So, once again, I'm doing equals. I always graph what's equal because that's my border line. That's how I do the line. 2x plus y equals 3. I'm going to try 2. I'll make x 0 plus y equals 3. If that's the case, if x is 0, then y equals 3. On the y-axis, x is 0, y equals 3. So I have gotten my y-intercept. I'm going to try another point, though. I need 2 points to make the line. I'm going to say 2x plus 0 equals 3. So I'm making y 0. 2x equals 3. Divide both sides by 2. X equals 3 halves. Be a little challenging, but y is 0, so I'm on the x-axis. I start at 0. I go up by 1/2, 1/2, 2/2, 3/2. So 3/2 is 1.5. I'll put my point here, and now I draw my line. And I extend it out throughout the entire graph. And in this case, for the first one, I still want a solid line. And I think about shading now. So to shade this, I'm going to go to a point. Actually, on this one, I'm going to try a different strategy. I'm going to pick a point on one side of the line and see if it works in that inequality. And the point I'm going to pick is the easiest point to calculate. The easiest number to multiply or add is 0. So I'm going to pick the point 0, 0. And I'm going to try that in my inequality. So I'll come back over here. 2x plus y, 2 times 0 plus 0, less than or equal to 3. Is that true? 2 times 0 is 0, plus 0 is 0. 0 is less than or equal to 3. Is that true? Yes. Since that is true, I know that this point works, so I am going to shade everything on that side of my line. If it hadn't worked, I would shade the other side of the line. I'm going to try x plus 3y equals negative 6. It cannot equal negative 6 because that sign says less than, but it can be very, very close to negative 6. So where x plus 3y equals negative 6, that's the boundary between what works and what doesn't. So I have to graph x plus 3y equals negative 6, and I will do that the same way. If I make y 0, x equals negative 6. So y is 0 on the x-axis, x is negative 6. That's off my graph. Don't want to do that. So I am going to make y something that's almost as easy to calculate. I'm going to, instead of making y 0, I'm going to make y negative 1. That means I have to add 3 to both sides to get x. So if y is negative 1, and that is going to be on this line, y is negative 1, x is negative 3. I am also going to try x equals 0. I tried y equals 0, it didn't work. I'm going to try x equals 0. If x equals 0, then 3y, trying to find a place where it won't be confusing. I'm going to do that over here. X equals 0. 0 plus 3y equals negative 6. I divide both sides by 3. Y equals, write it over here. Y equals negative 2. So x is 0. X is 0 on the y-axis. Y equals negative 2. So I've got 2 points. I can put in my line. So this was my first point. And this was my second point. And I'm going to leave this one as a dashed line because this one says, the second one says less than, not less than or equal to. It says less than. So I am leaving that as a dashed line. And that's what tells me that it cannot be equal to. But I need to think about where it is equal to in order to get the dashed line in. Now I look at my shading. I'm going to do the same thing. I'm going to pick a point that's easy to calculate. 0, 0 is the easiest one to calculate. So I do 0 plus 3 times 0. Is that less than negative 6? Is 0 less than negative 6? No. 0 is not less than negative 6. The point 0, 0 does not work. The origin does not work for this inequality. So I want to shade the area that does work. So everything below the second line works. So I look now at the area where I shaded for both. I shaded this area, the area below the solid line. I shaded the area below the dotted line. And ultimately, I want to shade the area that's below both lines. So I do not shade this area. Although it's below the solid line, it's not below the dotted line. And this area is below the dotted line, but it's not below the shaded line. So in my final answer, I shade the area that's below both lines. Um, okay. Try number three, and see if you can figure that one out. Thank you very much. Okay, equals 3 and 4. Let's check your answers. Here are the answers to 1 and 2, which I did. Hopefully your answer to number 3 looked like this. And your answer to number 4 should look like this. If not, please check your answers and let me know if you have questions. Thank you.